All right, we're going to look at a problem here that uses definite loops. Use a loop to output the first 12 perfect cubes in this format. Notice the complete sentences. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, ... 12 cubed is 1,728. So we'll jump over to Eclipse. Maybe before I do, let's go ahead and jump over here and make a new class. We'll call it cubes, CubeList, or cubes. How about CubeList? If you're on a Mac, you could indicate what package you're in. If you ever need to pause to see this more clearly, just pause it, go back, whatever you need to do. Okay, so here's our guy. I'm going to close that rectangle out. We're done with that. Public class CubeList. Maybe I'll go back here to this guy real quick. I don't know if there's a lot to figure out here in terms of analyzing the problem, designing the problem, pseudocoding it. The specifications, I mean, obviously, when you cube something, you multiply by itself 3 times. We don't have the math module yet, so we don't have the power function. We could use it. Maybe I'll do it after. First, we'll do it manually, just so a number cubed is multiplied by itself 3 times. You know, what would the design phase be here? You know, I think we understand this problem is pretty self-explanatory in terms of the analyze. What do you want us to do? Output the first 12 cubes in this format. The specification, again, not a whole lot to do here, except, you know, what's a number cubed? That's n times itself 3 times. But, you know, maybe in the design phase is where we could think about, it says use a loop. So how many times does the loop run? The loop, we loop from 1 to 12. And then what do we want to do inside that loop? We want to print a statement about the index, really, because the index here is 1, and we need to cube 1 there. And then when the index is 2, we need to cube 2. So I mean, that's essentially the design. And then we can jump over into the implementation stage. And just so that we are all on the same page, or again, you could be writing this down in your notes. By writing stuff down, it helps us learn it better. Implement 5, after we code it, we could test and debug it. That's a B. And then 6, maintain and improve. Maybe at some point, instead of just printing the first 12 cubes, we might ask the user, you know, how many numbers would you like to see the cubes of? And then the user would enter 400, and we would print the first 400 cubes. Okay, so we'll ditch the notebook stuff. And we'll come over to here, and we'll do our commenting. So some block comments here. Again, I just have to type the first forward slash and the asterisk. Let me show you that. Forward slash asterisk, and then I hit enter, and it'll automatically set it up. Put my name. Computer Science 142, the date 6/28. 20. Explain what the program does. This program will output the cubes of the first 12. Now, what I did not do scribe here, which is really what what this assignment is about, is that we're using a loop to do it. So this program will output the cubes of the first 12 integers, comma, using a definite loop. Because that's really what we're after to learn in this stage of our right now. Sorry. Okay. Because printing the first 12 cubes is easy. 1 times 1 times 1, 2 times 2 times 2, etc. Using the loop to do it is the new thing. So in our loop is going to run from 1 to 12. So here's the syntax for to tell it it's an integer. And since we're just using an index, we can just use the letter I, or we could use n in this case, but let's use I. And I is going to start at 1. So we declared it and initialized it there. And then the condition on which we stop is that I is going to be less than or equal to 12. And each time we want I to increase by 1. So we could say I equals I plus 1. And this will run fine. Put a semicolon at the end. And just so we can see this will run fine, we don't want a semicolon at the end. We want an open brace, excuse me. Because now we need to be inside this loop. Notice our braces. Eclipse will fill them in for us. There's the loop. That should be main. That should be the class. This is going to be the place where a lot of people make little syntax errors initially, is your braces are off. Sometimes you'll get a red bar, and if you have a red bar, usually the error is before the red bar. So oftentimes it's a missing or an extra. If I put an extra brace in here somewhere, then I get an error down here on that one because it doesn't know where that comes from. Okay. So ideally, you're letting Eclipse do these braces for you. It will set them up. So rather than starting with the cubes, this is sort of the iterative process. System.output.print line. Let's just print that variable I. And what we should get is 12 lines down, 1 through 12. So we're sort of checking that our loop is working, and it is. 1 through 12, boom. You know, nobody would ever write I equals I plus 1 like this. You can add 1 to I by doing I plus plus. That's the increment. We'll run it again, and we'll get 1 through 12. Java allows a plus plus in front. That means pre-add 1. I just wouldn't use it. It's not very common that you would ever need it. So just generally you can just use the plus plus after and not worry about it. Or the minus minus will decrease by 1. Okay, so we're almost done because we've just printed the first number, and if we look at what our output's supposed to look like, so you know, again, I'm kind of a stickler on this. If I give you a format for your output, you need to try to match it. So this guy starts with the number, and then it says cubed is, and then it gives the cube, and it ends with a period. So there's the number. So we'll add to it a string, and I'll say cubed is, and then I'll add to that I times I. And then we'll run it. And it's not right. I just want you to see that it's not right. So notice what I have. I have a lack of spacing. I need a space between the 1 and the cubed, and I need a space after the is and before the 1. So I need a space before and after in this string. And we run it again, and again, it's not right. The spacing looks good. Everything looks good. It's the first 12 perfect cubes. 1 cubed is 1, all the way down to 12 cubed is 1,728. If you go back and compare it against this, hopefully I want us to notice they're missing the period right there. So we get that by adding after this period at the end. Run it again. So that little bit of attention at the end to make sure that your output matches what we want it to be. And again, this is a very short code. Now we could clean up our white space, take that out, maybe take this out, take that out. It's a little easier to see it, more concise in there. That's it. Moving on.